A very good morning to everyone. So today we are going to start a new topic in design of steel structure. Is a very simple one, and this is our topic for today is slab base. Okay, let's jump. So here is the slab base, and yeah. So column bases are the three types of column bases. One is slab base, gusset base, and village foundation. So today we will deal with the slab base. Okay. So this is the thematic diagram. We can see this is the I section. This is the column. Actually, this column is connected with this steel plate, and this steel plate is placed over the concrete block. Okay. The actual representation is like this. This is the I section. Okay, this is the I section. This is the side sectional view. This is connected with some angle section. Using some angle section, this is connected with the plate, and this plate is connected by the concrete block using the bolts. Okay, so this is the I section. This is the clit angle. Clit angle means is the ISA section. Okay, this is plate, that means the base plate. Today we will design this base plate first, and then this is the concrete block. Okay, this is the plan view where you can see clearly this is the concrete block. Over the concrete block the base plate is placed, and this is the I section column. The I section is connected with this base plate using this plate angles. Okay, and these are the bolts. There are 4 bolts are shown over here. Now this is our problem. Design a slab base for a column. The section is given ISHB 300 at the 58.8 kg per meter, subjected to an axial load of 1500 kilonewton. So in this problem we are not taking into account the moment. So I will show another problem using the moment also. So and we are using a M20 concrete for the pedestal. Okay, this is a grade M20. So the steps I already sent in the previous class PPT format. I will also show the link over here. And this is the bearing. First we have to calculate the bearing strength of the concrete. This is 0.45 FCK. I told in the previous PPT. FCK, what is FCK? It's the characteristic compressive strength of concrete. Okay. So here M20 means the FCK value is 20. So this is 20, and I got the value 9 Newton per meter square, 9 megapascal. Now I need to calculate the area of the plate required. How to calculate? So simply P by our bearing strength. So the PU, that means the value of our actual load is 1500 kilonewtons. So 1500 into 1000, that means in Newton, and 0.45 FCK is 9. So I get the value 0.167 into 10 to the 6 millimeters square. This is the area which is required for the base plate. Now this is the base plate. Please see, this is the base plate. The concrete block is not shown over here. Okay, if the concrete block will be greater than this, it might be the concrete block. Yes. Now this is the base plate, and this is the I section, that means the column. Now the dimension of this I section I got from the code IS 800 2007. IS 800 2007. So you can go the table 16. Yeah, you can see the table 46. Table 46 and ISHB 300. Look here, ISHB 300. This is the depth value, this is 300, and this is the width of the flange 250. So I got the value and put over here. So this is 250 and this is 300. Okay. Now the projected part for the base plate. So in X direction I am taking as A, and Y direction I am taking as B, and I also consider the projection in both sides are same. That's why A equals to B and B equals to A. Okay. Once again I am resolving this part. Now simply ISHB 300, I got the value D and BF value, that is 300 250. I put the value over here, and then I need to calculate the A value. So simply how to calculate? Look, I need to calculate the area of the total rectangle. Okay, so up to this portion, this is 250 and it is A and it is also A. Similarly here also 300, here A and here A. So simply area will be 300 plus 2A. This is the L, this is actually L and this is actually B. So L into B is equal to 0.167 into 10 to the power 6. So the actual value of A is 67. So I need to take some greater value. So here the actual value of L will be 434. I am taking some greater value for the factor safety purpose. So 450 and 250 plus 2A. Here it will come around 300 something. So I am taking some greater value 400. Okay. So the total area which I am considering, that is 450 into 400, that is 180,000, which is greater than our area requirement. This is the area required. You can see 0.167 millimeter square is same. I just move the point over here, 166.67 into 10 to the power 3. So what will be the value of A by our this dimension 450 and 400? Simply just subtract the value. So the total of here is 400 and up to this portion it is 250. So A value will be 75, right? 150 by 2. So similarly the A value is 75. Similarly you can calculate the value of B over here also. This will be also 75. Actually A equals to B, so both are 75 actually. Okay, so value of A will be 75 and B will be also 75. Now the important part is the thickness of the plate. It can be calculated using the IS code 800 clause number 7.4.3.1. So this is the code. Here you can see, look, here you can see this is the thickness. So it can be calculated, and what will be the W? W will be the uniform pressure below on the sub base. A and B is the projected part and T is the thickness of the flange. So I just put the value. The W value can be calculated by P by A. So P is the axial load. So 1500 is 1000 again in Newton. This is the area that we are considering. So I get the value 8.33. I just put the value over here, and 2.5. This is 75 square by 75 because the value I get after considering the greater one, that is 75 projected part in in X and Y directions. Okay. So just as the A and B are both values are same, so they are 75 square, 0.375 square, and 1.1 is the partial safety factor, the material of the weld, and this is 250, and this is Fy hill stress, and ultimately you get the thickness, that is 19 mm. Okay. So the thickness is what I got for the plate is 19 mm, which should be greater than the value TF. Okay, so what is TF? The TF is the thickness of the flange, that is 10.66. Okay, now how can you get? This is as per IS 800 2007. So you can see the table 46. Table 46. Yeah, look, you can see this is 10.6 thickness of the flange. Okay, this is for ISHB 300. You can also get the value in steel table also, SP6. So in this way you can design the or determine the thickness of the plate for the slab base. Okay, I hope you understand. If you have any problem, you just comment on the Google Classroom. Okay, thank you.